Everyone, my name is Abhishek Sharma. First of all, I would thank to all of you for giving me this opportunity. In this video, I will explain my solution for the task you assign to every candidate for the selection process, and I will explain my approach and the final solution for this task. I will clear some objectives of the question or task you have asked. So first of all, I will walk you through the objectives from your your side. Like in this task, we have assigned, we are instructed to build it in JavaScript and TypeScript. So I used JavaScript and Node.js to run that JavaScript code. The requirements are like we have to create an email service class that works with two mock email providers. These email providers are not actual email providers. These are mock email providers. And the second thing, we have to implement retry logic with exponential backoff. Uh, to explain this, like whenever an email sending request is failed, then the system or the solution should retry it exponentially after a delay of exponentially time, right? It add a fallback mechanism to switch providers on failure. Uh, in this point, we need to make sure that our solution is more capable to switch between providers whenever there is a failure occur, right? Ensure idempotency to prevent duplicate sends. Like the thing I noticed here, in my previous solution, the first solution I prepared, in that solution, the email, like the requested ID, is sending with mock provider 1, also mock provider 2. So I fixed that bug also. I got this challenge, right? And next thing is implementing basic rate limiting, right? So rate limiting is really important because of we cannot allow user to try multiple times. We have to set a limit. So it is a good point. And for providing status of tracking for sending emails, I used console log for now, but we can use database or local storage to store these email sending request, like which email sending request is failed or pending or successfully sent. We can have all the records in database or or as well as in local storage also. So key features would be retry mechanism, fallback between providers, idempotency, rate limiting, and status tracking. For now, I'm not looking at the bonus points like circuit breaker pattern, simple logging, basic queue system. I didn't touch them. As per the guidelines, I used JavaScript and didn't use any kind of external library except the Node.js. Node.js, because of to run JavaScript code outside the browser on a server, we need something like Node.js. So, and I implemented the documentation of solution also, and try to make it organized in an organized way and clean. And as you have mentioned here, mock providers instead of actual sending email sending. So let me walk you through the solution I coded, right? So let me first remove this dummy request. Here, in the folder structure of the task, I use modular approach. to build it more organized, in an organized way. Like I used helper functions, like helper functions which are helpful to make it successful, right? And I dis I defined a provider di directory separately. Like in that directory, we have mock provider 1 and mock provider 2. As you have mentioned, we need to use two providers and email service class, which is our main class, which will handle all the things, right? And an entry point from which our service will start. Okay, so you can see this is the code for our entry point. This is our index.js, right? Here we are required imported the email service from this email service file, and we have a immediate invoked function here, function expression here in JavaScript. You know about, if you are understand JavaScript, you know this thing, right? So what it does, like this function calls automatically, and in this function we are using a for loop to make multiple requests, right? To make multiple requests, and this is uh, our instance of email service. This one this one is instance of our email service, and in this email service we have defined a send email function, which will whenever we want to send an email, we need to call this function with some parameters, right? So we have given parameters to this function, and this function will take parameters in form of object, right? In form of object. So this is the object we have provided to this request. Like we have used dynamic concept to apply to make sure the request ID should be unique. So we are always using I index. So it will always unique, right? So this will make request. Now let me show you the email service class. No, let me walk you through first from the helper functions, like the main functions which are help to uh, implement these all concepts, right? Like retry, key features, and all. So in the first I would explain retry logic, right? In retry logic, we have two major functions, only two functions, but it could have more functions also, but for now, to make it minimal, I use only two basic functions here. This is retry with backoff. As we have mentioned, our solution provide backoff, exponentially backoffs. So whenever request gets fail, it will delay the request for 1 second first time, and will exponentially grow after that, right? Here we can see delay will be multiple of 2 every time. First it will 1 2, then 4, then 8. It depends on the number of retries, right? How long it would go. Here we have a function which used to make it to wait it, right? Here we called it here to make some delay, right? And rate limiter, we have rate limiter function here. For now, I set the limit to 5. Like we can only send 5 email requests for the first time. After the uh, after a minute, like we have set here after a minute, and set count is equals to initially 0, and always uh, we have implemented a function here, check rate limit, right? If set count is greater than equal to limit, it will return false. It is a simple logic for now, but we can do so much things here, right? Else it will return true. So first time it will 1 and it is 0. So it is true false, so it will not run. This will return true, so uh, it will don't it will not interrupt the process, right? And it will work at every time. Now let me explain the idempotency logic. Oh, I commented this. I should uncomment it. Yeah, now it is good. Here we have two major sets, like the set for sent request is request, and the set for pending request. One will carry all the requests which are sent, right? And one will carry all the requests which are still pending. It needs to be sent, right? And we have two functions here. Sorry, three functions here. Like it will check is duplicate function, mark as in progress request, and mark as sent. So these three functions will be used to verify and make sure the idempotency. How this will work, I will explain in email service. Let me go through the status tracker. Right, it is a normal function. We just use the console log here and console log all the things. So it is a normal function. Now let me walk you through the providers. It is a mock provider, right? It is mock provider. As we can see, we have simple logic here for simulate the success or failure. We can have we can use these parameters to subject body to actually send the email. It is these parameters are given by the parent the at the calling point, right, where the function is called. We have these parameters. It is a fact to check the for the debugging I used one here, but for now I will change it to maths dot random function. It will return a random number, so every time it will check. For now I do it again. This is second one, right? Now let me go walk you through the email service. I will, as we use all these helper functions in our email service, I imported all the necessary and required functions here. Here we can see we have email service class. In this we have constructor, and we have majorly two variables here, like providers, which will store the our providers. So we have created instance of mock provider 1, mock provider 2, and the set and this set a limit and set a value to current provider index, like which provider is working now, to have a record of it, right? This is a main function of our class send email. It will send the request. We have called this function in index.js, like here, right? Now we can see here we are first of all having the request ID from the email request, right? Like we can see here we have requested ID. So requested ID would be this value, right? So first of all, I will capture. It is called destructuring. We are using destructuring here. So we are having request ID from the email request. Now we will check on the basis of request ID, is it duplicate or not. This is the function of idempotency. We can see here in this, it is here, right? So is duplicate, we provided we passed as a parameter request ID. So if it is, then it will return log status. Log status is a function of status tracker, right? It will have some parameters like request ID and some static parameters like duplicate and already sent, right? Now if the function, if this is not true, then it will move to this portion. Now the check rate limiter will work. Rate limiter, we have defined this logic in this file. It will check the limit of how many times it is already sent, right? So we have set the limit where it is here. So again, we called the log status taker function log status to log the output of it if the limit is exceed or not. And now it is the main logic to send email. Everything is fine here till here. So in this portion, we are applying a for loop for every provider, one and two, right? So we are applying from 0 to provider's length. And first of all, we will get the provider from the provider's array, right? By using the current index, we have defined current provider index to verify which to have exact provider which is now sending, right? And this after having the provider, now we will move to the next provider by using this logic will move the current index of provider. Now we are handling error here. We are doing error handling properly here. Like we apply try catch block here. It will try, right? It will try what for what? It will try retry. It is a function of retry logic, right? In retry logic, we have two fields, like two parameters. It is needed, like a function, callback function, and the rate limit, right? So we pass three here. Like a provider can only send up to three times continuously. After that, it would delay for some time. Then we'll try. If it is properly sent the uh, email, it will mark the request ID as sent. It will add the request ID in the set we have defined here. Here, yeah, where rate limiter? No, idempotency, right? We have defined this here, mark as sent, right? Okay, so if this is successfully sent, is if this process is successfully sent, then we will log the um, track of that email sending request. If it is successfully, then the status would be success and sent via provider name, right? If it is failed, then we will see the catch the error and log that error. If all the providers are failed and all the number of retries are failed, then we will log requested ID, error, and all providers failed. This is the kind of walkthrough to code portion. Now I will run this portion also. Let me run it. Node index.js. Right. So we can see here the requests are successfully sent. First, the request ID is 2. Let me move to the request ID 1. It is a request ID 1 and which is sent via mock provider 1. Now it is changing to mock provider 2 for request ID 2 and alternatively sending the emails. Let me show you a case where the mock providers might be failed. If I do it like if I return false every time here, then it will throw error, right? Let me do it one. It is a fact which is not true, right? So it will always return false. It will throw an error. So let me run it again. Now you can see output differently, right? So for request ID 1, like you can see for request ID 1, we tried for via mock provider 1, but mock provider 1 is returning what returning? It returning false, an error, right? So it will switch to mock provider 2. So now request ID 1 and successfully sent via mock provider 2, right? And we can see 5 also here, mock provider 1 and see. If I do this thing, this to effect, what will happen? Let's see. Oh, you see, all providers are failed, right? All providers are failed. It is kind of good thing. It is a random logic and simple logic, custom logic, right? So this is the service I built. I hope this would help me to get more and to go ahead in the process, selection process. I wish I would select for this for the next round. I will be selected for the next round. Thank you so much. Let me walk you through my repo also. I defined a repo. I created a repo on GitHub. Your repositories. Here we can see email services. So I uploaded all the code and README file here and the folder structure also and a simple description about the repo, right? A resilient email service repo built by using purely JavaScript. So it is my solution to your problem. Let's see if I'm selected or not. Thank you so much.